And over to you.
Okay.
Well, welcome. Thanks for coming to Scaling Oban Applications. So I'm Parker, and this is Shannon. We've been business partners for 15 years. We are obviously husband and wife. This is one of the first times we've done this with pants on for the rehearsal. So. For your benefit.
American pants, you're welcome.
Most importantly, we are the people behind Oban.
And I'm Shannon. And when I'm not supporting Oban customers, I am cooking world cuisines with a myriad of spices. It's something I love. My dog.
Our dog.
Our dog. I love our dog. I dislike the bottom of swimming pools. I mean, so much so that if it's pumice, I will do anything to avoid touching it. Really dislike the feeling.
And I'm Parker. And when I'm not fixing things in Oban, usually that I broke, I love eating world cuisine with a myriad of spices, maybe cleaning up. I truly love big chunky tires like you find on tractors or construction equipment. It's like a boyhood fantasy carried into adulthood. And I loathe backing up an Airstream on a really crowded street. It's harder than it looks.
He's very good at it.
I try. But this talk is about scaling Oban applications. But we're going to start with some things that may or may not scale very well.
Cargo ships. Cargo ships scale incredibly well. They're something that look like they shouldn't cross an ocean with all of our goods, and yet they do. They transport, and they do it well.
Trains scale very well. This one's overscaled so much that it's covered in people all along the side.
My favorite is the guy at the front making a phone call.
He's got things to do.
And it's working out. But not everything scales. Your grandmother's knitting, perhaps, she cannot knit for your customers, your clients, the entire family. Her poor little hands are going to freeze up.
And they wanted $80 for this on Shutterstock, so pardon.
Yeah, you're getting a Shutterstock logo.
Well, the BEAM and Erlang OTP is renowned for scaling horizontally. And it's so ubiquitous that it's reported that 50% of the world's internet traffic goes through Erlang nodes, and it's uniformly used for 5G in the US and in Europe.
We all know that Elixir scales. That's why we're here. It's been shown to scale time and time again. You may remember the road to 2 million WebSocket connections showing the process model scales.
But slightly more obscure is Elixir RAM and the template of Doom, which demonstrates that the I/O model also scales. And if you've never seen this article before, it has the stellar endorsement of Elixir is more interesting than any programming language you've ever seen in your life, which, how do you argue with that?
Ever. And as a database, Postgres is renowned for versatility and its ability to scale vertically and horizontally, as illustrated by Earth's largest land mammals, which start off incredibly small and become majestic behemoths.
This is a Postgres pun, in case you didn't catch it. It's an elephant.
It's low fruit, and I'm not above it.
She let me have it. More practically, Postgres has been known to scale to 1 billion inserts a second, which is in certain optimized situations, and well beyond the reason of what you'd need for a background job queue. And that's how we're going to talk about this, which is Postgres as a queue. And we're going to be overtly technical for a second, but in the past 8 years, Postgres has made a lot of progress in adding new features that make it scalable and work as a queue. Starting with, in 9.4, they added JSON-B, so you can have a hybrid document SQL relational database. Very important. Essentially, in 9.6, they added skip locked, which is like the secret sauce to being able to have queues at all without contention. And 12, they added reindex concurrently, which lets you rebuild your indexes to minimize space. And then in 13, they added B-tree deduplication, which is important when you have a state machine modeled as a queue, because there are a lot of duplicate rows, and it's important to be able to prune through those quickly. And then in 14, they added optimized skipping B-tree splits, which I don't know what that means.
You should look that up.
I'll make a note of that.
It's a good plan. Oban is the sum of Elixir and Postgres, components that meld wonderfully and complement each other. I'm sorry to disappoint any SQLite fans. I'm not saying you should leave the room right now. You will not self-destruct, but you're already on your path to global domination, and we're not doing that today.
So we know that combining Elixir and Postgres scales well. Many of us have applications built on exactly that stack, and they work out really well. The question is whether Oban can also scale. And in the past, we've shown that 1 million jobs a minute is possible in a single queue, on a single node, on a mere little laptop.
That's a blog post, which is
That is a
great.
blog post. It has a blog post with some fancy charts
Okay. Well,
that showed that actually it gets closer to 2 million jobs a second, and that is also possible.
charts are fancy, charts are data, but not always proof.
We'll go to the next slide. We have proof. So this is an HTOP screenshot, which shows that 4 cores are heavily utilized, while the other 6 are really not doing much, and that's while the demo was running. So you see all those idle cores doing nothing.
Well, you know what they say about idle cores, Parker.
It's a great band name, idle cores.
So it can scale the small, but what about the large? Can you push 1 million jobs in a minute for a whole day? Which is well over 1 billion jobs a day.
Yes, 1.4 billion jobs. Yes, you can.
So it's a little teaser about what we're attempting to do that we'll tell you about later. We're attempting to do that right now while we're giving this presentation. So, little live demo at the end. Hopefully it all works out according to plan. Brazen, huh?
No pressure.
No pressure.
Well, we're going to show how you can tune queues for maximum throughput. And you can also minimize impact on the rest of the application. These are essential qualities for scaling.
Minimize impact on the database and avoid the dreaded bloat.
Personally, I don't bloat.
He says that.
Physically, this is not something that's a problem for me.
Yeah, you say that all the time. You say
Yeah.
you never bloat.
I'm in good company.
We're avoiding that. That's our job, to avoid the bloat.
So we're going to talk about some practical problems, causes, and solutions, things that are easily identifiable in your own applications, why those are happening, and then what you can do very quickly to address those. And we're going to start with
Quick fire tips. So, minimize the size of your job's arcs. There are several benefits to storing minimal values, like IDs and arcs. 1, it's less data over the wire to the database. 2, it's less data stored and less data indexed. And 3, it's resilient to updates or changes, or if the job is retried later, which it most likely is.
have some confidence.
I'm going there.
So you should also prune aggressively to get rid of old jobs. So historic jobs, the ones that are completed, canceled, or discarded, they just build up in the database, and you don't need to keep them around. So by letting the pruner run in the background as a plugin, it will delete those to free up the database, make room for uniqueness queries and introspection. And also, use insert all whenever possible. This is a pretty standard rule for application use. Don't insert one thing at a time if you don't have to. It's just the laws of physics. If you make one insert, it has to go over the wire back and forth. So bundle those up into one insert if you can. That's fewer queries, fewer transactions.
Each insert operation is a round-trip query to that database, so update your Postgres version. I think we'll say that, 2 or 3 times? Maybe more. So upgrading is difficult. We don't want to say that it's easy to coordinate that. We all know that it is. So every Postgres version, it improves performance and adds helpful features. It's worth it. It looks minimal, but we know it's not.
But really, have you thought about upgrading your Postgres version?
He harps on it.
Oban only supports back to version 12, and it's currently on version 16. There are a lot of improvements between those 2 versions. So you get free performance and extra features, and when we inevitably bump that requirement, you won't be left behind. So seriously, consider upgrading. It's hard, it's worth it.
After you update, scale your database. The most immediate when possible is to vertically scale your database. The effect is instantaneous and the cost is marginal-ish.
Sure. So now, some real-ish life scenarios. This is based on feedback that we've gotten. People's emails, Slack messages, whatever other support channels we've gotten. And these are based on real problems, identifying the causes that were behind them, and then going through some practical solutions.
And the names have been changed to protect the innocent or avoid direct harassment.
Innocent.
Lave Ducia. Lave asks, why does our instrumentation show PG Notify at the top of our frequent queries?
It's a very Lave question.
It's so Lave. Well, Lave does two things that are great. He asks the question, and he provides proof. So we investigate. Clearly, that's happening. Oban uses pub/sub notifications for communication between nodes, like job inserts, pausing queues, resuming queues, and metrics for web. The default notifier uses Postgres because it doesn't require any extra setup. Every notification requires a separate query. We tried using a single connection, it bottlenecked and tanked at scale. So, what do we do?
You start by rolling back, trying to use a single connection, because that doesn't work. That's actually a very bad idea. And then once you've done that, you tell everybody to try to use a different notifier, like PG or process groups. That minimizes your load on the database, it gets rid of your total queries, and it allows bigger payloads. It's a win all around. And if you have a functional cluster, and I mean distributed Erlang cluster, not Kubernetes or some other sort of cluster, then it's a single line change. You just go from Postgres to PG. And Portis Retro says, inserting jobs generates too many notifications from the database. Can we disable that? Well, good news for Portis is yes, you can. So inserting jobs emits a trigger, and the trigger is a notification that lets any running queues know that there's something for them to fetch and execute. And it does this so that between the 1 second polling time, you can have a very immediate responsive job fetch. Originally, that was part of Postgres. It was done as a trigger in the database, hence the name triggers. But that doesn't scale very well when you do bulk inserts, because it has to deduplicate all of those. So what do we do to fix that?
Well, managing triggers from Oban itself provides more control, and it's made it possible to have triggers with other notifiers, like PG, which is better for scaling. Evaluate if you need a sub-second job dispatch. Without it, jobs may wait up to 1 second before running, but that's not a concern for busy queues since they're constantly fetching and dispatching.
And if your application's busy, that's what they're doing.
It's a good thing. Disabling the triggers is a single line of configuration, and if you upgrade, there's a teeny tiny database migration.
It's not painful at all.
Just a teeny tiny one. Millip Fiden, that's a real name.
It's the most realistic one so far. Yes.
Millip asks, how do I stop open job indexes from taking up so much space on disk? Well, Millip, the transactional model applies to indexes as well as tables. That leaves bloat from inserting, updating, and deleting jobs. And the auto vacuuming won't always fix that. So, the index situation gets better after version 14, but they're still prone to bloating. So how do we fix that?
Well, the bloating problem, which is not a problem for me.
Clearly
but for
never
others,
you.
Is to reindex. So use the reindexer plugin to intermittently, concurrently, without any locking or any downtime, rebuild all of those essential indexes. So that does a couple of things. One, it minimizes their size on disk, and it also optimizes them to make your queries faster. It's part of open source Oban, and you can just add it to your list of plugins. Normally it runs at midnight by default, but if that's a little bit too aggressive, then you can tweak it. It uses a cron-like schedule, and you can have it run weekly instead. And Jevin Laxon says, inserting bulk unique jobs times out sometimes. There aren't that many jobs. What's going on? It's very sassy.
It's very Jevin.
So, well, the problem is inserting unique jobs requires an extra query whenever it's inserted. So one query is to check for existing jobs, and the other one is an advisory lock that ensures that different transactions don't compete with each other. And when you stack those up, instead of making a single query to insert a job, you actually have 3 queries. And that doesn't scale very well, despite the fact that they're very fast. The checks just aren't free.
Many things aren't.
Yeah. So,
what do you do? Frequently, people set uniqueness for jobs, and they don't really need it. This happens a lot. So first, evaluate whether or not uniqueness is necessary for your workload. Reduce the work to match jobs by selecting a single field rather than an entire JSON field. It's important. Avoid checking the unique period if at all possible, and if that's not possible, set the timestamp option to scheduled at.
You might wonder, why isn't that the default? Well, it just didn't exist back then. So for legacy reasons, we can't change it, but now that you know, you can change it and make it all better.
We can use that as an index. So, as shown here, it's just a few lines of configuration in your worker. So,
Now,
shameless pro tip.
and now a word from our sponsor. So in Oban Pro, the Smart Engine can do bulk unique inserts in a single transaction. So instead of 1 query per job and 1 advisory lock per job, it does that in just 2 queries, and then it inserts them all together. Fewer queries, fewer transactions.
Wogan Wager. Wogan asks, how do we stop seeing ectoq timeout errors from Oban when our application is busy? Oban uses connections from your application's repo pool to talk to the database. When that pool is busy, it can starve Oban of connections, and you're going to see timeout errors. On the other hand, despite fast queries, if Oban is an extremely busy thing at that moment, it's going to starve your application of connections, which is not what we want. So how do we fix that?
Well, a good solution is to set up another repo, a secondary one that's dedicated just to Oban. So Oban can use it to fetch, act, and do the other things that it needs to do without competing with your application for those resources. So the dedicated pool isolates those queries. It's really easy to set up as well. You just point it at the same database, a little bit of configuration. It doesn't need a lot of connections. Oban actually uses very few connections by itself most of the time. And it's a single line change to your config to just point it at the other dedicated repo. So, Wen Bilson, he says, pruning old jobs works well, but the size of our jobs table is bloated and it keeps growing. Again, with the bloat.
It happens. This happens often.
So, problem is, like indexes, the transactional system only flags rows for deletion later. And so when you delete, it then has to flag it, and then AutoVacuum comes around and it empties it. But it still doesn't actually get rid of it off the disk. And the more that you run these things, the busier that it is, the more garbage that you accumulate. And so you have to tune, well, I don't want to give that away. I'm sorry. The default settings aren't that great. So what do we do?
Well, I mean, auto vacuuming can be tweaked for the Oban's jobs table alone, just solitary. And the exact scale factor, it's going to vary. I feel like this is unusual because it will be based on your unique situation, your table rows, your table size, and your database load. So
there's no one
that's
size fits all.
general, I'm sure.
Yeah.
But it does lead to a shameless pro tip.
So pro tip number 2, which is OpenPro's dynamic partitioner. Instead of having to use a pruner for deletion, it partitions old jobs and by state, and then it manages dropping those entirely. And when you drop a table, there's no bloat left over. There's nothing at all. It's virtually instantaneous, and another benefit is that all of those tables are smaller, which means they have less activity, and auto vacuuming is faster for all of those as well.
Tonika Munsky. Tonika asks, why do we start to see connection errors under peak load in high concurrency queues? Well, Tonika, fetching jobs takes a single optimized query for each queue. However, acking when a job finishes takes a single connection for each job. So, in a busy system with high concurrency, all of the acking causes pool contention. And despite the individual queries being very fast, this is still something that we have to solve. What do we do?
Well, you've heard this one before, but increase your pool size and reduce your overall concurrency. The ratio between the number of jobs executing and the number of available connections in your pool has to be tweaked to minimize any competition that's happening. So start by using a dedicated pool. Again, we said it before, it's really very important. When you have a dedicated pool, you know a baseline of how many connections are available for Oban compared to your application, and they don't mix. That gives you better predictable performance. And then in extreme cases, when you're running 100 million plus jobs a day, you might want very predictable performance, and that's when you might think about having a dedicated database just for Oban jobs, which can help. So here's an example, a somewhat trivial example, of increasing the pool size, minimizing concurrency. It's not always that simple, but just consider if you need 50 jobs running at a time, or if 30 might work. And the final pro tip is Oban Pro Smart Engine acts all those jobs together. So instead of a single connection and transaction every time a job finishes, it bundles them all together and waits, and does that in a single transaction the next time it fetches. Far fewer transactions, far fewer queries.
All right, I think it's time for some tips. So the first one, isolate Oban from your app. It's probably the 4th time we've said that in the last 5 minutes. It is the #1 quick fire tip that we could give to you out of the scenarios that we see most often. Minimize extra transactions, which is very similar to
Minimize extra queries. Again, fewer queries, fewer transactions, better off for your app. Also, minimize index bloat and minimize table bloat.
all right, it's time to put up or shut up, right? So
There's a good chance of shut up. We'll see.
it worked earlier, and this is always what happens. It works through the run-through, and you decide you're just going to go for it. So
the idea is we take all of the tips here, we put them together in a single application, and that application actually runs in the background. And it should be capable of running what is 1 billion jobs a day on a laptop, just locally, while we're giving a keynote.
oh, look at this. All right, go ahead and run it.
Oh, and no. You can see the configuration, but it's not happy about it. So,
You can try to restart.
yes, I'm going to move it over.
Oh, that's always the thing. It's so nice to be
No.
in a room full of friends when you put yourself out there with a live demo.
Maybe not the best idea for the live demo.
I think it was a great idea.
Oh well.
We can always go through the code, though, as well.
I'm trying to get it off of. No? Oh well. All right.
There you go.
No.
You're on both. Okay.
All right, so there's all of the configuration put together, which we really promise can run 700,000 jobs a minute in better circumstances than these. And if you put that all together, that's over 1 billion jobs a day. You can see triggers are disabled, the notifier is changed, it's partitioned, it's not pruning, and it's a little bit of all of those things put together.
And I can bet you if you find us outside an hour from now, he will have this running to anyone
Just
who
come
wants
find.
to come up
There'll be a
and
little
check.
dashboard. You can look at it. It's got the things ticking in. Let's see.
You can try to print it again, though.
Yeah. I can't see, so.
Well,
Doesn't like it.
are you getting red?
Yeah, we'll see.
Come on.
I think I don't know if we have time or not. We started late.
All right. It's disappointing.
All right.
Well, I'm sorry to let you down. But that's the bravado of a live demo during a talk with 2 people, right? So We're so pleased to be here with you. It's so nice to see all of you. If you've spoken to us online or if you want to speak to us for the first time, we're very happy to meet you. We're so appreciative of our people and the Elixir community, and we're so proud to be here. Thank you for your time. Obrigado.